Okay, so this is my RepRap. I've only done a few prints so far. It is only just built, so there are still things that are not permanently affixed yet, like the circuit board, which is just resting on a piece of bubble wrap on top. But it's working for the most part. Still having like working in problems. But it seems to be printing well. Here it's printing the parametric appliance knob. It's available on Thingiverse. It's not my design, but we have an appliance that needs a knob. So, here we go. It makes wonderful noises, I think. So a few facts about the printer. I used it's a Prusa Iteration 2, so it's got the T2.5 belts, and it's got a Greg's hinged accessible extruder on it. All the usual things. I haven't used the copper PCB print bed. I've built my own with a piece of aluminium and some nichrome wire. And I've wrapped the edges in Kapton to seal the gap between the aluminium and the wood. It just prevents kind of air from flowing underneath, and therefore the bed gets a lot hotter, and the objects stick to it, which was a problem I was having originally. It's just another RepRap with, you know, standard end stops and standard this and standard that. There's nothing particularly special about it, so I just wanted to get a video of it so that I can show my family what I've been going on and on about for the last few months, and show them that it's finally producing results. So here you can see it's doing, what's it called? Honeycomb infill, which I think is a bit smarter and looks a bit sturdier than rectilinear. And it does Hilbert curve on the bottom, which is very cool. For the software tool flow, I am using Slicer to slice the STL files, and Print Run to control the printer. And obviously it's a Sanguinololu. Did I say that right? Sanguinololu. So it's running Climate's Sprinter firmware. All in all, I think it cost me around £400, maybe a little more if you include things like P&P and so forth. And the main reason I've got it, the main reason I built it was my final year project at university next year is going to be building an FPGA based controller for it. So there are a couple of things there. I can use a software-hardware co-design to hopefully implement an accelerator for G2 and G3 codes. So it should be able to print a lot faster, well, slightly faster, because it'll be able to print in actual curves and not and it doesn't have to parse a crap ton of G1 codes to print a rough curve. It'll also, obviously, it is embarrassingly parallel. I love that. In that you've got four different axes to control. You've got the temperature controls, all of these things should be happening in parallel, not sequentially on the processor. So all of these can, in theory, be different IP cores, each running independently on the FPGA. One notable thing for my printer at the moment is, as you can see on the right, the power supply is not an ATX power supply. I was going to use an ATX power supply, but then I remembered that my ham radio power supply puts out 13.8 volts at 23 amps, so I decided instead just to use that. I don't think there's anything else that I've got to say. If you have any questions, ask them in the comments. The end stops are standard. Yeah, I've run out of things to say now.